It's possible to make all sorts of roll tube mechanisms to simulate real sort of machines and mechanisms that we see in everyday life. So let's assume we've got our little prism to start with. That central point there could act as what's called the pivot, and if we make a very simple seesaw, well, the pivot would be in the center. So there's a long tube that I've made. Can you see with this one I've put extra tape on it because we don't want to put tape near the ends, but we do want to try and make it stronger. And what you find is if it's a moving part, sometimes it can be under greater strain than the normal sort of fixed tubes. So if you make it stronger by putting a bit more tape on it, it helps. But remember, wherever you're going to punch a hole, maybe avoid putting the tape there. You can use a stronger punch altogether and that would be fine. But if we were to punch a hole in one end and then attach on to the rod, well, there's nothing attached to that end and we're free to move. So if you think of, there are lots of examples, you can think of all sorts of examples of where a tube might be the arm of something that moves. So this could be, for example, if there was a string on the end and a hook, that could be a crane, a very simple crane. I think it needs a lot more work to make it into a better simulation of a crane. Or it could be a seesaw. The pivot point would have to be in the middle, so I'd have to punch a hole in the middle. It could be, I wonder if this gives anybody any ideas. Let's see if we had what? An elastic band or a stretchy material which could move the lever. Then the lever arm could actually throw something. Of course, the Romans and medieval people made all sorts of machines based on a structure and then a pivoted rod. So that might be a ballista for hurling something, and our simple model might have an elastic band that can make it move. So there's a lovely little challenge for you. Make some longer tubes, try different hole punch points or pivot points, try attaching them to the structure and see what sort of machines or mechanisms you can come up with. We've looked at a bridge and a tower. Well, of course, towers are used in siege machines. Maybe this next idea could be a siege machine tower which incorporates a machine for firing boulders as if you're going to storm a castle. So siege machines is a fabulous opportunity for making roll tube mechanisms and simulating what people really did. Here's a point about the moving levers. When you make a small roll tube, then it's tightly rolled. It's got lots of paper rolls in it. But if you've used the paper sideways, the other way, then you haven't got as many rolls, so that's not as strong. So quite often what people do is combine tubes together. So if you wanted this tube to act as your arm, well, one tube isn't really good enough for that. So if you make a second tube, and then the second tube was to add onto, the second tube adds on, together they form a stronger lever. So the throwing arm might end up something like this. Look, let's pop that one back in. Now you don't want it as two separate arms, but you do want them to work together. So bring them close together and then get some stick tape and wrap it round both of them. So now we've got a throwing arm, if it was used in a ballista, that's twice as strong as before. So there it goes. Maybe a bit of tape around the back as well to strengthen it. So there's a lovely little challenge for you. Could you possibly make a siege machine or a ballista for firing rocks, and could the elastic band in some way be attached in order to do that? So there's a lovely little problem for you to solve. A roll tube mechanism, a siege machine, all made from paper tubes and 3 wooden dowels. Fabulous. There's your challenge. Give it a go.